Welcome to the first video on factors and highest common factor. This video covers C1, F1 and F2. In this unit, we'll only be working with the natural numbers, the whole numbers greater than 0 that we count with. For example, 1, 2, 3, 4 and so on. That means that in this unit we won't be working with negative numbers, we won't be working with decimals, and we won't be working with fractions. First, let's investigate how natural numbers are put together. For example, if we start with 12, we can ask what numbers can be multiplied together to give 12. One example is 3 times 4. Since we can multiply 3 and 4 together to make 12, we say that 3 and 4 make a factor pair of 12. Members of a factor pair always divide exactly into the original number. So in this case, 12 divided by 3 is 4 exactly with 0 remainder, and 12 divided by 4 is 3, and that goes exactly with 0 remainder. Now let's find all the factor pairs of 12. We start by writing 12 equals, and then the factor pair that involves 1. Every number is 1 times itself. Next we write 2, and we ask what can we multiply by 2 to get 12, and the answer is 6. Then we write 3. What can we multiply by 3 to get 12? The answer is 4. Next we write down 4. What can we multiply by 4 to get 12? The answer is 3. But now we spot that we're beginning to repeat ourselves. We've got a 4 here and a 4 here, and a 3 here and a 3 here. So that's really just the same pair twice, and I don't want to double count them, so I can cross out this last pair. So I have 3 factor pairs, 1 times 12, 2 times 6, and 3 times 4. Here's another example to find all the factor pairs of 15. If you want to have a try, pause the video now. We begin by writing 15 equals, and then always start with the factor pair of 1 and the number itself. Then we write down 2. Does 2 divide exactly into 15? It doesn't, so there can be no answer here. Next 3. Does 3 divide exactly into 15? Yeah, it goes 5 times. Write down 4. Does 4 divide exactly into 15? No, it doesn't. Write down 5. Does 5 divide exactly into 15? Yeah, 3 times. But we notice we're repeating ourselves again. We've got a 5 here, and a 5 here, and a 3 here, and a 3 here. So we've repeated the same pair again. So we don't need this pair. And in general, when you start repeating yourself, you know it's safe to stop and you've got all the pairs. So here I've got 15 equals 1 times 15 and 3 times 5. We just saw what were the factor pairs of 12. They were 1 times 12, 2 times 6, and 3 times 4. The numbers that we can see on the right hand side here, taken together, are called the factors of 12. And if we list them, we can see that they are the only numbers that divide exactly into 12 without leaving a remainder. And that's the definition of a factor, which you can read here. As an example, let's find all the factors of 20. We'll do this in 2 steps. First, we'll write down the factor pairs. Next, we'll make a list of the factors. Start by writing down 20 equals, and first we write down the factor pair that's 1 and 20 itself, because 20 is 1 times 20. Next, write down 2. 20 is 2 times what? 20 is 2 times 10. Write down 3 times, but 20 isn't in the 3 times table, so there's no factor pair there. Write down 4 times. 4 times 5 is 20, so 4 times 5 is a factor pair. Write down 5. Well, now we're going to get 5 times 4, but we don't want to count the same factor pair twice. We've got 4 and 4 and 5 and 5. We don't want to double count, so there's no extra factor pair there. Next, I want to make a list of the factors I've found. Here are the numbers in our list. And we simply list them in order: 1, 2, 4, 5, 10, and 20. These are all the numbers that divide exactly into 20, leaving 0 remainder.